Welcome to part 4 of our guided tour of Boilermaker, the code we use for senior phase projects. In this video, we're going to talk about the user model, passwords, hashing, salting, security, OAuth, authentication, passport, sessions, everything involved in knowing who people are. So let's start with the DB folder has a models folder that's got our user in it. Okay, so there's a user, index, and a user spec. Index is just going to tie all our models together to make them easily exported so we can import the models folder and get all of the models. We can glance at it quickly, but it's not got much in it. It just exports an object with the user in it. So let's go look at the user. All right, and this is a little bit more intriguing. So we've got some fields here. Something that you should always keep in mind with SQLize models, the define method takes 3 parameters. The first one's the name of the model the name will become the table name in the database, or it'll be pluralized by SQLize. SQLize will actually take your name and turn it into the plural version. And it uses a library called inflection.js to do that. So user gets translated to users. Then the next parameter is this object, which is all of the fields that actually go into the database table. So these will become columns or attributes if you prefer. So you got email, password, salt, and Google ID. And then there's a third parameter, which we're not using here. It's optional. And that'll be options to customize some behaviors of this table and define special things like hooks or getters or whatever.
And I think one of those is if the library doesn't know how to pluralize it correctly, like for instance, if your table name is octopus, and it's like, well, it doesn't know if it's octopuses or octopi, which technically it's octopuses. I hope everyone knows that, but maybe it doesn't know, and you want to give it its own name. That's the kind of thing you could specify in options.
Yep. So SQLize, I don't remember what version we're on now, 4 something, I don't know. It used to be that everything would go into this .define, but then they changed it slightly and they made it a little bit more like idiomatic JavaScript classes where you can add static and instance methods by adding to the .prototype or just to the function itself. So if we scroll down in this user, there are a couple extra things in here. There's some instance or prototypal methods like .correctPassword. There are some static or class methods, generateSalt and encryptPassword. And then there are some things that are not JavaScript specific, but SQLize specific, like hooks. So user.beforeCreate is a function that SQLize put onto the user object that is a hook registration system to say, hey, before any SQLize rows are actually created, run this function. So let's start with the fields. I think that's a pretty logical place to start. What have we got here?
So this looks to me a lot like what you might see in just any database if you described a table. So we already created our database and we actually seeded it. So I can look at this if I connect to Boilermaker and I can show my tables. Let's describe users. Okay, and so it has all of this information, and as you can see, it has exactly what we have, but a few other things that SQLize adds for us: created at, updated at. But we don't really need to get into that. It's really this part that is reflected here, and you can see that reflected in the model.
Now, did you run the seed? Are we seeing some actual users here? It's difficult to tell with the narrow window. It's messed up the formatting slightly.
Yeah. Well, no,
I think it renders based off of,
I only did the scribe.
Oh,
but
okay,
I can.
Sure.
We can look at the users.
Yeah, let's select star from users.
Okay, we only have 10 or 2. So,
sure.
In this case, where, like you said, because it's wide, it's really kind of annoying. There's this nice thing in pSQL. You can do -x, and this will, instead of listing them horizontally, it'll list each record vertically.
Nice. Yeah, cool. So we got 2 records in here from our seed. Email, Cody@email.com, Murphy@email.com. Cody, if you didn't know by now, is Tom's adorable pug. Cody, the coding bootcamp pug. And we have the things that SQLize added by default, created at, and updated at. But then we have password and salt, and here they look like gibberish. Let's look at our seed function again and see what actually went into that.
Sure.
So the 2 users we created were Cody and Murphy, but Cody's password was 123, and Murphy's password was also 123. If we look over what's actually in our database, the password is gibberish EC4, etc. And for Murphy, it's 26F, etc. So even though they have the same password, what's stored in our database doesn't look the same. And this is the idea of salting a password. So hashing gives us gibberish, and salting gives us even more gibberish. Every user is going to have a unique salt that's randomly generated. The salt isn't a secret. It's just to make it so that every password that gets stored in our database is unique, even if two people share the same password.
And this could be a problem when you have a popular service and you have weak password requirements. Let's say that you have a game and you're like, I don't care how strong people's passwords are, it's really not going to matter. But then later on it gets really popular and then you start adding more sensitive details. So all of a sudden now it matters. But unfortunately for you, you didn't have very strong password guidelines at the beginning, and so users could have entered something like password. So instead of trying to crack all users, like they find a user and try to crack their password, they could just try the word password on many different users and possibly get in that way. And so salting also mitigates that sort of attack.
Yeah, if you didn't have salting and you discovered that somebody's password was something weak like PASSWRD, whatever, PASSWRD, then you might, if you had somehow cracked and got access to the database and you saw that all these other users have the same string of gobbledygook, even though you were hashing the password, now an attacker knows that all those people share the same password.
Exactly, yeah.
So let's take a look at how we actually implement this in our user model.
So I think it must be those hooks you were talking about.
Yeah, it's in the model itself. So we have, let's take a look at the fields first. The fields themselves are password is a string and salt is a string. I'll talk about those get methods in a second. They're a terrible hack that I ranted about in Slack earlier. But they're basically just two strings. So where do they actually get set? As you were saying, that's the hooks. So before creating an individual user or updating an individual user, we'll run the setSaltAndPassword function. User.changed is a SQLize method that says if the field we pass in, which in this case is password, is different currently from what this model looked like the last time we checked it in the database, then run this function. So if we are going to change the password, if we have modified the SQLized JavaScript object version of this row, then generate the salt. So come up with a new random salt and encrypt the password putting in the user's desired password and this salt.
Yeah, and here's our generateSalt function that we added. So,
yeah, it does this crypto.random bytes. So it gets 16 random bytes, base 64 encoded. And our encryptPassword, given the plaintext password and the salt, it uses the crypto library and the SHA-256 hashing algorithm, which is a popular hashing algorithm. Not necessarily the best one, but for all intents and purposes, good enough.
It's better than MD5 or SHA-1, for instance.
Yes. And we are going to change the plaintext, put that into this function, and also put the salt into this function. And by hashing it twice over, we get a gibberish version of the password that is unique, even if somebody coincidentally had the same password as someone else. That we can see we're returning from that encrypt password function, and in the line in setSaltAndPassword, we are taking the gibberish it spit out and storing it as the user's password. So that's how it gets into the database. Now let's say somebody was going to actually log in and they say, oh, my username is dakota@email.com and my password is 123. What happens next?
Well, ideally, you don't want to take some secret token like a password and pass it along unsecured channels. So before all of this started, hopefully you have an HTTP connection so that if you do pass this across the wire, then it's secure in that way. On the other hand,
you said HTTP.
Oh, I'm sorry, HTTPS.
There we go.
Thank you. Yeah. HTTP would be an unsecure wire, and you wouldn't want to do that. But you could even mitigate it in that circumstance if you hashed or if you computed the token on the client end and then checked against the back end. But the best thing to do is to have HTTPS so that it doesn't matter if you do it on the client or the back end. So then you take your password and you do the same thing, because we have this encrypt password And the same protocol should be used for any sort of challenge. So this is a challenge that the user is responding to. The user says, I can regenerate this value using a secret that I own. And so we apply the same thing. We say, all right, give me your password. We take that. On our end, we look up the salt according to that user, and then we update it, the digest, and then we compare the two, and we say, well, is this digest equal to that one? And if they are equal, then we let them in.
Exactly. And that's exactly what we're doing in our instance method. If we scroll up, there was an instance method we defined called correctPassword. Given a candidate, like somebody's trying to log in and they say my password's 123, we do the same process. We take the salt, we take the password, we put it into this encryption function, we generate some gibberish, we check it against the gibberish in our database. If they match, then it must be that this person knows the right password. Now, the word must there is interesting from a mathematical perspective. From a practical perspective, it's absolutely like they must know the correct password. The universe could like start and stop, multiple times before someone would accidentally guess a different password that gives the same result for this function.
And what you're alluding to are hash collisions. And the reason that a hashing algorithm like SHA-1 is not super appropriate for this context is because collision attacks are possible. Not like MD5, where rainbow tables, which are basically just use every possibility, where you can look up, given a hash, what the value is. That sort of attack doesn't work so well, but these collision attacks do work well. But no such vector has been found yet for this hash.
That's another scary thing about this is a weird aspect of this security is there's no mathematical proof that it's actually secure.
Right.
It appears for all intents and purposes to be completely secure. Nobody's figured out any way that it's not secure in the sense that it's unpredictable. Nobody's figured out a pattern that it follows that's easy to analyze or get ahead of time or be able to reverse engineer. But there's no proof that it exists or not. It's just like, well, lots of people have tried and they've all failed, so it seems practical.
Yeah, and this algorithm has been around for a long time. So here's hoping.
Yeah, it's security through it's been subjected to a lot of attacks.
Yep.
And we would probably know if it's unsecure by now. Okay, so that's cool. That's most of the user. I mentioned these weird gets. Can you take a look at that, in that salt right there?
Yeah, I noticed down here we're checking the equality by actually calling this value. So it's like this.password, but then we call it as if it were a function.
Right.
And that must be related to this, I would expect.
Yes. So what you can do in SQLize is say, I'll store it in the database one way, but when I read it in JavaScript, I'll look at it in a different way. What I've done here, which I'm not a fan of, this is my least favorite thing that I've personally ever done in code, is say, well, I want to try to avoid, this is me being paranoid. I want to avoid paranoid / just trying to challenge myself to see if I could do it. SQLize doesn't have a notion of private fields which you want to have access to on the database side, but never leak to the front end. So normally, if you get a user object from SQLize, it'll include the .password and .salt fields. That might not matter so much given the security measures that we've been talking about. But I was interested to figure out, is there a way we can prevent those fields from leaking to the front end, from being sent over to the client side? So this was my very hacky solution. I said, well, make it so that instead of being .password, which is a string, make .password a function that returns the password string. Why does this matter? Well, you can always read it in the server by just calling the function. If I do this.password invoked, I can check what the password string is. That's fine. My server has total access to this stuff. But if I res JSON a SQLize instance, converting it to JSON, if you take an object and convert it to JSON, it skips any functions. So the .password is a function. JSON stringifying it means, oh, just don't include the password. So this is me trying to come up with a trick so that anytime it was going to be JSON stringified, it would automatically omit the password and the salt.
This man saves your passwords with one weird trick.
Yeah. A more semantic way of doing this, which I am strongly looking at maybe refactoring this in the future, would be to explicitly say, let's define a SQLized scope. That scope would be the default scope. And the default scope would use a blacklist or a whitelist and say, please deliberately omit the password and the salt. The only problem I have with that is if somebody defines their own custom scope, the default scope no longer applies unless they remember to include the default scope too. So there is a small but totally possible passive chance that someone could accidentally omit that safety protection, that safety layer. And this way is a little bit more likely to catch more edge cases where anytime it's being JSON stringified, no matter what scopes they started with, then it will be, automatically stripped out.
Maybe those will be some good tests to put on our default test suite.
That's a really good point. Let's go look at the user spec. I don't think we have those tests at the moment, but we do have some tests. So let's take a look what we got. We're pulling in our database connection, pulling in our user model. Before every spec, we are force syncing the database. We talked about this in an earlier video, starting from a clean slate. And we're going to check out, usually some things that are good to check in SQLized tests is if you write any class or instance methods. Functions are a really good thing to test, making sure that they behave the way you expect. Testing tons of model fields like, oh, users have a name and the name is a string, I don't think that's a really valuable test.
Mm-hmm.
That changes frequently, and it's usually the kind of thing that if it breaks, you'll know it breaks pretty quickly. Functions, on the other hand, are behavior, and behavior has a lot of cases that you need to double check, and they are typically a decent thing to test. So what are we testing? Well, we got this correct password thing. So we create a user with a given email and password. We put in the password and we check that the correct password works if you put the correct password in, and it says false if you put an incorrect password in. So this is really good. You always want to falsify in your experiments. It's not enough to say, oh, if I give it the right password, it says, yes, that's the right password. You also need to check that if you give it the wrong password, it says false. You need to check for the wrong behavior and make sure that you get what you expect.
And in general, any sort of logic path we have, if you have several different things that could be one or the other, you want to test all possibilities. So here we have password. Is password correct? And that's 2, so we need to check both.
Yep, and this cuts into what Matthias Johnson of MPJ, like fame, Fun Function, if you know his video series, he calls the combinatorial explosion of test cases.
Yep.
The more options you give a developer or a user, you have to multiply all those options out to actually check everything. And the way to do that properly is with loops. So we could do a loop in our Mocha code, which first checks everything with a correct password, and then checks everything with an incorrect password. And for every one of those loops, you would check the next thing. So maybe you want to check if the salt function works properly. So then it's like, if the user is correct and the salt is incorrect, what do we get? If the user is correct and the salt is correct, what do we get? And so on and so forth. And with these loops inside of loops inside of loops, you can very quickly generate lots of test cases. The promise A+ spec is the spec that says whether promise libraries behave correctly or not. And it's got over 800 tests, all through just that combinatorial explosion of, well, if this is on, then this is off. Then we have to check on, off, on, off, on, and off, off. And if you add another thing in there, now you're talking about 8 possibilities and 16, it keeps going up and up.
Exactly.
All right, that's the user model, the user spec. So the next thing we're going to check is some OAuth authentication passport stuff. And that exists mostly in the auth folder of the server, and also a little bit in the server index file itself. So we looked at server index before. Let's go back to it and see what we glossed over.
Yeah.
Okay, so we looked at a lot of this, but one thing is we've got this passport.serializeUser and deserializeUser. Can you explain what that does?
Sure. So we could possibly store sessions in cookies. And we could say, all right, everything that the user is doing on our website, we're storing that in a cookie. The problem with that is that the cookie is going to be much bigger. Like if we say, if they have a profile picture, we might say, oh, here's their profile picture, and that's part of their session for whatever reason. If we try to put that in a cookie, that's pretty big for a cookie. So it's going to lead to, they might say, oh, this cookie's too big, I'm going to delete that, or what have you. Something that we don't want to do. Also, it could possibly, as you said, leak information. Like if we store too much user identifying information in that cookie, if, heaven forbid, we have a cross-site scripting attack on our website and somebody's able to read the cookies of our users, they could possibly pick up on that information. So to the extent that is possible, we want to limit the amount of personally identifiable information in the user's client information. And so by serializing this user, what we're doing is we're creating an identifier for this user session. And so right now it's just the user ID. It's like, hey, this user's logged in, this is their ID, and this is going to be one of the main things that identifies their session. It's like this user session corresponds to this user ID, and that's all it is. It says this person is logged in now.
Definitely. So Passport being a OAuth library that helps us with login and sign up, not just locally, but with providers like Google and Facebook. Passport asks us about a bunch of questions. One of the key questions Passport wants to know is, how do you want to uniquely identify users? And if you have an identity for a user, what kind of information about the user do you want to restore every time somebody makes a request? So serialize means to take some dynamic memory structure, convert it to a string, and store it as a string. Deserialize means it takes that serial string and convert it back into an object, a dynamic memory structure.
So it's almost like encryption or encoding, but just for a different purpose.
Right. This purpose is, let's collapse it down to a tiny little piece of data, and then deserialize is take that tiny piece of data and expand it back out to being an object. So how do we do that here? Well, serialize is simple enough. We take the user and we just put their ID in. Deserialize is the opposite. Given an ID, we look it up in our database and we tell Passport, here's the full user object. What's the, I was going to say use case, but I really mean what's the consequence of this? Like now that we have this, like what do we get out of it?
Well, as I said before, we can make our cookies smaller, but we can also communicate with any third-party auth providers about our users and not have to worry about any sort of information getting out other than the user IDs.
Sure. Another way of looking at it, though, is like in our routes, there's a specific concrete side effect that these two functions cause, which is really useful for our routing.
Oh, are you referring to the req.user object?
Exactly.
Yes.
Yes.
Right.
So this is something Passport does is if somebody is logged in, Passport will take their information and put it onto the request object as req.user. And that's what's happening in deserializeUser. Given the ID we stored in the session, fetches the actual user object, we give it back to Passport. Passport says, okay, here's req.user equals that object. And we could use that in our routes.
We could even show an example of that if we wanted.
Yeah, that sounds really good to me. Why don't we do that?
Sure. So I think what I would like to do with this is change the default route, and instead of saying hello world, it says hello world user. If we can do that, I don't actually, now I'm wondering if I can do that. So this is our server index, and in our route here,
maybe we'll make a custom route for this.
Yeah, that's probably the best. Okay, so then app.get, just any sort of GET request, and I'll just give it a name, test. Okay. What I want to do is I want to make a new route, so I need a request, response, and next objects, and so what I want to do here is I'll just res.send req.user, so we can see this. Okay, so that should work. So over here I was testing, just running the tests, and now I can start the server again, just starting the basic without compiling anything. I didn't change any of the client code.
Yeah, I don't think.
And if I do /test, it should give me
We got the home page.
It didn't. Is
do we save?
Yep, this is saved.
So app-get /test.
Yep. That's
the kind of like mindless trivia. It's like, oh, okay, we need a slash.
I need to restart the server, actually, I think.
Yeah. Another disadvantage of not using the dev script.
Exactly.
All right, so there we go.
Great. So it's empty because I'm not logged in.
Sure.
And this is what we expect.
Yes.
So let me log in as Cody. Well, really embodying that pug life. So here we have this, and then if I go to test, I can see, it's my user.
That's req.user. And this would be really helpful if we also had like user roles. So we had like an admin field, and in our routes it could say like if req.user.isAdmin is true, then do something and send a response. Otherwise, send a 401 unauthorized or something along those lines.
Yep.
Okay, so that's the serialize and deserialize user. We also see there's a route here for app.use/auth. But before we go into auth, let's just double check like the top level of this file, or the top of this file. What other passport stuff is going on here? We require in passport, and then a little bit further down, passport registration, we do serialize and deserialize user. Is that everything? So here we have, right there. App use passport.initialize and app use passport session. These are just boilerplate copy paste. This is what you need to do when you have the library. You want to sync everything up. You need to connect Passport to Express, so Passport automatically supports certain routes. And so that Passport will read in from this session, which is done with Express session, information it needs to fetch the user ID and then create req.user for us. Because Passport integrates with our session, it stores the user ID in the session, but Passport doesn't manage the session directly. It just uses the existing session. Okay, so let's look at our auth folder. So we have an index and a Google. I guess we know where to start. And we have some local strategies here. We got or local routes, and we've got some OAuth routes. If there's anything, if we go down to the bottom of this, I think there's going to be something. Yeah, any request that's going to be for /auth/Google is going to go into our Google file. Let's start with our local authentication. This is the stuff where we have a user in our database who they've signed up with a password with us and an email address with us. We're not borrowing Google or GitHub as an authentication service. So if they post to login, so post because they're sending a body, then we will try to find a user whose email matches the email in the body, in the posted body. If there is no such user, then we will send a 401, an unauthorized. You cannot log in as that person because that person doesn't exist. If there is a user, but the password that the user posted does not match the password in the database, we looked at that a second ago, we send the same 401. It's considered to be good practice to not give too much information about why it failed. Like, oh, that was a correct username, but the password isn't correct. Or even worse, oh, that was a correct password, but the username was incorrect. That doesn't make sense. So we just say 401 in another case. Otherwise, login. Now this req.login comes from Passport. When we did Passport initialize, it added a method to the request object called .login. This is a way for us to manually set req.user in a way that Passport knows about, so it can properly sync up with the session and so on and so forth.
Yeah, and as we can see, it's a res.json user, and my browser recognized this as JSON, and that's why it prints it in this nice way.
Yep. Something that's really important is missing from this route. And there's actually an issue about this in GitHub right now.
Oh.
Can you, if I was doing this as a code review, I was testing you as a student.
Okay, so let's see. If there is no user, if the user doesn't have the correct password,
I'll give you a hint. It has nothing to do with authentication per se. It's a little bit more of like a generic JavaScript mistake.
Oh.
Yeah, it's nothing even to do with Passport or the libraries at hand. It's really just JavaScript. Like this is the sort of thing on MDN somebody would call it out. We have an async function
Mm-hmm.
And in that async function, we're awaiting on the first line.
Mm-hmm.
But what if that promise throws an error? What if it rejects? What if it's a rejected promise? So this is a thing that is going to be solved by the time you all look at this video. It's really easy to miss, and I missed it when we converted everything from promises to async await. And I was reviewing somebody's code where they did this, and I didn't see it. And I found it later, and I was like, oh, I missed that when I was reviewing this. So
I missed it as well.
Yeah. So. We should wrap this into try catch. And if there is a catch, if there is an error, we'll pass the error along into next. And that's really important because otherwise we'd have an unhandled promise rejection. And right now, unhandled rejections just give console warnings. But in the future, at some unspecified date, an unhandled rejection warning could crash the entire server. And we wouldn't like that. And
you'd like to do something like this, like what you said. But the problem is now I have to work out defining it. Yeah. Well, I have to do, let user.
So that's one way of doing it. The other way is just wrap everything in the try. Mm-hmm. And then if any of it fails, catch and put the error into next, which I think is what I would do in this case. Or there's a library out there by a former fellow called Express Async Handler, which can do this kind of automatic try catching for all of your routes for you, which I think is nice. All right, so back where we were, that's a login. Try to find the user. If it doesn't exist, send a 401. If they have the wrong password, 401. Otherwise, set the user to give the user a password. Do req.login, which sets req.user, sets it in the session as well because of passport.serializeUser. If there is an error asynchronously, then send the error over to Express. Why do you think that doing req.login is asynchronous? This is tricky.
So req.login is asynchronous. Well, it has to create the session, and we're storing the session in the database. So that could potentially be another server call, like another HTTP, not HTTP, but over the internet.
Yeah, TCP call.
Yeah, TCP.
Exactly. This is communicating with the session, and because the session isn't necessarily inside of our Express app or our Node app, but it could be a service like Mongo or Postgres or Redis, it is asynchronous. Let's take a look at signup. It's going to be very similar. Try to create a user with that email and password. If that fails, and because it fails because of a unique constraint error, that's because the user already exists. So we're telling them you can't create a user by that name. That email is already being used. There's kind of no getting around that. Either you tell them like that email's taken or not. So we can't completely hide the fact that users have certain emails.
Well, you could. If you were willing to exclude certain emails from being allowed. For instance, if you used a Bloom filter and you allowed false positives to this test, saying that, oh, well, you can't use that one. Not that it doesn't exist, but for the purposes of this signup, it does exist.
Sure. It's forbidden for reasons that we will not specify.
Yeah.
If we do get to create it, again, we do req.login to let Passport know about it, let Passport serialize the user of the session, and set req.user. And if we make a request to log out, we do more passport-based stuff. Req.logout is a passport method. It was given to req by passport initialize. It removes the user from the session, and it deletes req.user for us. The next method, req.session.destroy, is an express session method. It's not a passport method. And it takes one even more aggressive step, which is not only does it say, for a given client that's connected to us, this user is no longer logged in. It also says, forget that that client is even connected to us. And if they connect to us again, it's as if they're a brand new client. It's not necessary to do that for the purposes of logging out per se, but we're just kind of really going whole-handed. It's like, okay, we'll just forget about that computer entirely. And then tell the client, hey, go to the homepage because you've logged out, and so you should just like not be looking wherever you were looking. Get/me is saying who's currently logged in. The front end has amnesia. If you refresh in the browser doesn't know what was going on anymore. It's starting from scratch. So the first thing the browser will do is we'll ask the server in our client code, we'll say, hey, was I just here? Like, who am I? Am I logged in? And the server will say, yeah, you were just here. You're logged in as this person.
Let's see if it remembers I was logged in as Cody. This should fail. Oh, no, I guess I didn't delete
we're currently still logged in.
Okay. But I can also go to me, which should give me the same result.
API, or auth me.
Oh, auth.
Yeah.
Yep.
There we go. So auth me is whoever the currently logged in user is. And that's useful in the front end when you start running your client-side code and you want to know, like, is the user logged in or not? Well, the front end has to ask the backend that because only the backend really knows. Security only exists truly in the backend, although there's things you could do in the front end to help. And yeah, what about OAuth? What about Google? Let's take a look at that file. So we're building up an inventory of stuff we understand with Passport here. The ultimate goal here is Passport gives us req.user, which we can use in our routes to test things about the user, like are they an admin? Do they have a name? What's their email? Req.login is a way of manually setting who the user is. Req.logout unsets the user. And let's take a look at what if somebody wants to log in using Google? Well, OAuth is beyond the scope a little bit of this video series. We're going to give you a refresher, but if you really need the details for the entire OAuth cycle, we recommend you go back to the workshop on authentication and view the review code and review videos for that. So we're going to want to connect to Google in this case, although it could be GitHub or some other service. And in order to do that, we need to do what Passport calls is setting up a strategy. We need to tell Passport our secret password that like our server knows to talk to Google, so that Google and the server can swap information. We also need to say a verification callback. So this is the point in an OAuth sign up or login where a user has proven to Google that they are who they say they are. Google bounces the user over to us, telling the user, hey, now that you've proven that you are a valid Google user, tell this server that. From our perspective, a user comes back to us and says, I just talked to Google and Google said everything's okay. And we're like, did you really talk to Google? Did they really say everything's okay? I'm going to have to check that. So the user says, here's this token, this string Google gave me to prove it. Why don't you go talk to Google and see what they say? So we end up in this state where Passport on our server talks to Google, gives Google that verification token. Google says, yep, I just gave a user the same token. That must be the person who's trying to log in and they are a valid Google user. And they come back to our server in the verification callback. Let's take a look at what that gives us. It's further down.
Sure. And that's what's here.
Right here. This arrow function with token refresh token profile done. This is the function that gets called if Google confirms that the person trying to log into us is a valid Google user. Not only do they confirm that, yes, they're a valid Google user, therefore it runs this function, but Google gives us in that profile parameter normalized information, data about the user, such as their email address. Other stuff too, like their avatar. If we ask for special permissions from the user, like I'd like to read your emails, it might have extra stuff in there. So Passport asks us a question, us the developers at this point. Passport says, Google's confirmed that the user is a Google user. Here's the user's Google info. Which user does this correspond to in your database? So we need to use their profile information to either, if they're signing up, create a new user in the database or look up a user that's already signed up in the past. And that's what we're doing with find or create. Let's find a user whose Google ID is this user's Google ID. If they exist, we'll give it to Passport. That's that .then user done user callback. Give it to Passport, which means Passport creates req.user, sets the session, etc. If we cannot find a user with that Google ID, we'll create one and we'll give it the name and email that came from Google. Either way, if we end up in that .then with a user, we tell Passport, here's the successful user. We either found it in the database or made it in the database, and now please set it as req.user and we'll continue along our merry way. If for some reason this find or create fails, like it cannot create a user with that email, but it didn't find a user with that Google ID, which would be a weird state for our database to be in. Something went wrong. We catch and we give it to Passport so that it's aware there's a problem. Now, if the verification callback runs, This is all, by the way, like copy paste, like boilerplate. You got to set it up and just copy paste it from project to project. If the verification callback succeeds, we find or create the user, hand it off to Passport, which means req.user has been set. Passport does one more thing. It goes to the success redirect, which is configured further down. Right there. It tells the front end, yes, you are correctly logged in. Please go to the home page. Or, oops, there was a problem. Please go to the login page. So that's the really high-level overview of what we're trying to do with these strategies. We're trying to say that once Google or GitHub talks back to us with the user data, how do we match that data to our database and then tell Passport that everything's good? That's the essential question we're trying to answer. Let's go back to the top and see if there's anything we missed. Why don't you take over?
Well, we didn't talk about where we get this information.
Yeah, that's a good point.
And we have to negotiate with Google somehow to get this. And there was a time whenever we were doing the OAuth lecture the first time that I gave it, and we were doing the workshop, and we were like, okay, everybody go and sign up for a client ID and client secret. And you can do that in Google's website, but there were three cohorts working at the same time: Chicago, New York full stack, and New York Grace Hopper. and this system is not meant for the millions of users that Google normally operates on. So it started breaking, and it was a little confusing. But I think at that point the students, a lot of them switched to just doing GitHub, almost exactly the same thing, just copy paste, changing Google to GitHub, and it almost all worked. But yeah, for each authentication provider, you will have some sort of ID, just saying like, "Oh, this is me. This is my app." And the secret is your shared secret, saying like, it's basically the password for your app. And then the callback URL is going to be where Google sends that user information. Like whenever they redirect the user, where do they go? And
yeah, the essence of OAuth is any two people. It's typically relatively easy for them to confirm that they know each other. So our app can talk to Google or GitHub, and it proves that it's our app using this ID and secret. Mm-hmm. The user can talk to Google or GitHub, and they can prove who they are with their username and password. But the user wants to talk to us and prove that they're a given Google user. That's why OAuth starts to get complicated with a lot of this going around the circle. Mm-hmm. Mm-hmm. Exactly. So you're right. In order for this Google strategy to work, Passport's going to need to talk to Google and prove that we are who we say we are to Google. And for that, we need this predefined ID and secret that we set up as developers with Google. So we would do that, as this comment suggests, in our secrets file. We would set up this thing ahead of time and save it in our secrets, and then it would work. What else do we got going on here? If it doesn't find those, by the way, it just doesn't bother to run any of this code, which is nice. It means the server doesn't crash.
But it's also looking for them in the environment variables, so they can be in our secrets file or set as environment variables in our environment, like in Heroku or some other way.
Definitely, and that's a really nice kind of like flexibility to have. It's like have it set as part of our environment, whatever OS we're running in, whatever shell we're running in. Or use this secrets.js as a local development thing. Cool, we've created a strategy. We've talked about that. We've said, hey, Passport, please use this strategy. So that's just wiring it up. And now we have a couple of routes. We say if somebody tries to get auth/Google, then please Passport take over from here. Eventually, after the user and Google and Passport have all talked to each other, we end up in that callback that we showed. Mm-hmm. And we call done to say, here's a correct user. At that point, the user is going to automatically make a request to /callback. And we do this Passport authenticate. And if the verification callback succeeded, we redirect the user to homepage. Otherwise, we redirect them to the login page. And yeah, if you want to make something like this with GitHub, as Dakota pointed out, it should be mostly copy-paste. The only thing you're going to have to change a little bit is mostly what goes on inside of that verification callback. Here we get normalized data. One thing that Passport does that's really nice is that profile information is not a raw version of the object that comes directly from Google or from GitHub. It's normalized. Passport tries to take disparate providers and create this profile object that looks the same no matter what the provider is. So even some of this stuff won't have to change that much. At the top, we're pulling in, to create this Google strategy, that constructor comes from a library, Passport Google OAuth. You'll have to look up what the right library is for other providers like GitHub or Twitter or whatever, Facebook.
But in mathematics, this would be called mutatis mutandis, meaning only change what needs to be changed.
Yes, it's a good strategy. Wow, we've gone over a lot. I am trying to think. I think that's pretty much everything we wanted to talk about with OAuth and Passport on the back end. There are some front-end routes, but we'll talk about that during our Redux and React components. Okay, see you in our future video. The next one's going to talk about Redux setup and Redux testing. Ciao.